Hello everyone, welcome to our channel Public Cloud Design Tips and Tricks. In this channel, we generally discuss about public cloud design problem statements and the related solution. Today, we are going to discuss about GCP Istio. Today's problem statement: in a Kubernetes-based ecosystem, how to provide observability, security, and reliability to applications with a standard layer of infrastructure. So the developer will focus on writing on the business logic rather than focusing on this taking care of all this stuff. The solution which has been provided is service mesh. There are a lot of open source service mesh which is available in the market like Istio, Console, Linkerd, and many other native service mesh solution is also available via Google Cloud provider is Google Cloud Anthos. So when you are splitting your services from monolithics to microservices, then Kubernetes is the way to go. But when you are having your microservices running inside your Kubernetes cluster, there are a lot of challenges which has been observed. So when you are looking into the challenges, the first and foremost challenge is the communication. What do you mean by that? Let you have your services which is running inside your Kubernetes cluster, and at that time a web server which is running in pod 1 is trying to interact with the payment server which is running in pod 2. That means the endpoint of the payment server needs to be registered in your web server. That means the communication needs to be established clearly. Second, security. When you are running your applications inside your Kubernetes cluster, you have Kubernetes firewall generally, which is there to restrict the access to the cluster. And also there are many proxy solution like Nginx and other gateway solution which is available with which you can invoke your Kubernetes cluster. But once the attacker is inside your cluster and once they bypass it, then inside your cluster, the communication between the services is very light. That means it is very unsecure. It generally follows some HTTP kind of protocol with which they can invoke any other service. That means your attacker is inside your cluster. Then after that, it can do whatever it wanted to do. So you have to make sure the security inside the cluster is much more stronger. Then the monitoring, you definitely need to know how many times a service is getting invoked, who are all services who are invoking that services. All the monitoring and traceability aspect needs to be captured. The retry mechanism also needs to be established so that when you are invoking a service and the service is not available during that time, then that should be a kind of solution where you can retry the invocation to get that service available. And at the end, you have to also write your business logic for which you are configuring all this cluster. So if you focus on configuring communication, security, monitoring, tracing, retry, and all of this aspect, then you will definitely be distracted from writing the business logic rather than focusing on the infrastructure management. That's where there are a lot of automated tools which is available, and service mesh is coming to solve that solution by the solution of proxy. So what does it say? Service mesh will create a proxy out of it where your communication, security, monitoring, tracing, and retry mechanism can be configured effectively, will be applied to all the pods in the form of proxies, and you as a developer will focus on the business logic. That is what the layer segregation is, the definition of service mesh. This is the fundamental. Now let's try to understand what is a proxy, and in this case we are talking about Envoy proxy. Envoy is a layer 7 proxy and communication bus designated for large modern service oriented architecture. The network should be transparent to the application. That means when a network and application problem do occur, it should be easy to determine the source of the problem. That means whether it is by the network layer or by the application layer. That is why this service mesh applies the Envoy proxy in your pod so that your segregation will be clear whether it is due to business logic or due to the configuration. Now, what is the definition of Istio? Istio is an open source service mesh that helps organizations run distributed microservice based apps anywhere. Istio enables organizations to secure, connect, and monitor microservices so they can modernize their enterprise apps more swiftly and securely. So that business logic will be the focus point. And Google Cloud has leveraged these capabilities of Istio in its cloud platform so that you can leverage this service. When you are talking about benefits of Istio, That means it helps you to manage the traffic between the services. That means canary kind of deployment. You can think about a service which has been deployed a version 1 inside your cluster, and there is a version 2 which has been deployed, and you want to try the validate the version 2 or 10% of the traffic and 90% to the version 1, and after that you will split the traffic again to version 2 completely and you will remove the version 1. That can be configured via the service mesh, and Istio has the capability. So this is what the traffic splitting capabilities, access policy, who can access your services or who are all having the permissions. These are all can be defined there. Aggregate telemetry data. So your Prometheus kind of solution also can be integrated with your service mesh like Istio, where you can aggregate all your telemetry data and send it to your your monitoring location or logging location. It also helps you. The main logic is segregate business logic from your infrastructure. That is the benefit of Istio. Now let's try to understand the architecture of Istio. So Istio converts high-level routing rules that controls traffic behavior into Envoy specific configuration and propagates them to the sidecars at the runtime. So it enables these proxies during as a sidecar during the runtime. That means when a request is coming to your cluster, it will first go to the proxy. It will check the proxy allow the request or not. Then after it goes to the service A, and then again it comes to the proxy. Via the proxy, it will go to the service B via the mesh traffic. That is what the data plane it does. Control plane is nothing but which will take care of the proxy lifecycle. That is where the proxy control plane is coming. That means when you are having a YAML file where you are writing all this configuration and doing the kubectl apply, it will go to the galley. Galley will read this data and then it will send to the Citadel. Citadel will validate this data, and once the data is getting validated by the Citadel, then it goes to the pilot, and pilot will verify and create a proxy out of it, envoy proxy out of it, and applies to the respective pods. That is the basic fundamental behind the Istio architecture which has been followed. So this is how a kind of discovery configuration certificates which has been applied to your control plane via the control plane to the data plane, and they will discover the respective services identifiably. And this is the basic architecture of Istio. I have gathered all this information by following this link. If you like the video, then don't forget to subscribe and go through this document so to get more information. Thank you.